we have to find all the zeros. So this is good to talk about because I know the temptation on these is just to try to look at the calculator to get the zeros. But what is my expectation? What are you going to have to do for the test? P's and Q's and possible zeros. So, the p-values. Where do we look to get the p-value? The constant. So my constant is -2. So my p, everything that goes into -2 will be plus or minus 1, plus or minus 2. Q comes from where? Leading coefficient. So that's my 4. So everything that goes into 4 will be plus or minus 1, plus or minus 2, plus or minus 4. So then to get possible zeros, what do we do? P over Q. So 1 over 1 is 1, 1 over 2, 1 over 4, 2 over 1 is 2, 2 over 2 is 1, and I've got that. 2 over 4 is a half, and I've got that. So these are my possibles. How many zeros should we have here? 3. There is no guarantee that all 3 of them are on the list. Remember, this only gives us the rational ones, the ones that can be written as a fraction. So what do we do to find the first zero from here? Graph it on the calculator. And what are you looking for? Okay, so what's one value that works?
2.
So then, once you have 1, you do synthetic. I expect to see this synthetic. Take those out. Take them out. Thank you. The other one too. Come on. All right. So we have to do this synthetic. If you guys try to skip this and only give me things from the graph, you are losing a lot of points here. So we do our synthetic. So we get 4x squared plus 4x plus 1. What do we do from here? Slip and slide. So what multiplies to 4 and adds 4? 2. And then we have to, so that reduces to 1/2. So we get 2x plus 1 and 2x plus 1. So make sure you are answering the questions. I asked for the zeros and the factored form. The factored form includes the x's still. So that's the 2x plus 1 squared. What else would you have with that? And the zeros is if we set these equal to 0. So that would be a -1/2, multiplicity of 2, and a positive 2. Oh, on the slip and slide, not going back and writing. It's an easy thing to forget.
I was with Angela. How did I mess this up?
All right, let's look at 11. I want to go ahead and talk about all of 11, if that's okay with you guys. So I gave you this graph. This is FT, MN, and 80. All right, the first question asks you for the minimum degree. Let me just ask you some questions. If I'm looking at this, what kind of degree does it have to have? It has to be even, right? Because it's both ends are going the same direction. How many turning points does this have? 3. So remember, the degree is 1 higher than the number of turning points. So that means the degree has to be at least 4. B, minimum. So local min is not necessarily the lowest on the entire graph, just lower than the surrounding. MN. See local max, so we have two of those, the high points, A, B, and ST. Do we have an absolute min? No, there is no lowest on the entire graph because it keeps going down. But we do have an absolute max, the highest on the entire graph, AB. Domain, since this keeps going. In the range, you come from the bottom up. Good. Number 12. So we'll definitely have one of these. If I look at this, I see it hits the x-axis at -2. So my -2 is a 0. But what happened at -2? It bounced. So that means the multiplicity is 2. Where else does it hit the axis?
-3.
At 3. And then you can also find the y-intercept from this. So where does it hit the y-axis? Okay. So I have to take that information and write an equation to go with it. So if -2 is a 0, what do we have to have? Since it was a multiplicity of 2, that's a squared. If 3 is a 0. All right. Now, how would I factor the y-intercept into this? What else can we do? We can have a number out in front. And so we know a y-intercept is when x equals 0. So if you put in a 0 for all of your x's, this thing has to equal -3. So we get -12a equals -3. So -3 over 12, -12 is 1/4. So my polynomial is 1/4 x plus 2 squared x minus 3. So you can expect to have one of those on your test, or I give you a graph and you have to write the polynomial. Make sure you are looking at your y-intercept when you do that. Is that one okay? Is there anything else from the study guide itself that you would like me to go over?
Pretty confident, to be honest.
Pretty confident? Should have just done the test today. Okay, here's what we're going to do. Just kind of running through a couple things that I didn't necessarily ask on here. How do you know if something's a polynomial? You had some on your study guide that said, is this a polynomial? What?
No fraction.
No fraction exponents.
Variable.
You can't have variable in the denominator. Okay. The degree we know is the highest power. Does it have to be the first term? No. So you want to definitely make sure you're looking at all terms to find the degree. So this one is definitely a polynomial because all my exponents are nice whole numbers. What is my degree?
4.
4. So how many zeros will this have? 4. The number of zeros is the same as the degree. So the end behavior, because it's a 3x to the 4th, end behavior should be FF. Possible zeros. So that asks you for your P's and Q's. So my P, everything that goes into 8, will be 1, 2, 4, 8. Q, everything that goes into 3, plus or minus 1, plus or minus 3. So possible, P over Q. So 1 over 1 is 1, 1/3, 2, 2/3, 4, 4/3, 8, and 8/3. Did we get that?
Yes.
Okay. D, factored form. So to get to the factored form from here, you have to find one zero that works. And we use the graph to kind of narrow that down. What is something that works? -1. So we do synthetic with -1. Okay, so 3 comes down. That'll be a -3. Adds to -10. Okay, at this point, you have a 3x cubed minus 10x squared plus 4x plus 8. Is that something we can easily factor? No. So what do?
Do another 2 works.
Yeah, find another one that works, and we'll do synthetic again. So 2 also works.
Question.
Shoot.
It doesn't matter which one we do first.
No.
Not being a W.
All right, what do we do from here? We need to factor it. So if we try slip and slide, is there anything that multiplies negative 12 and adds to negative 4?
Yeah. -6 minus
Okay.
Divide those by 3. So we get x minus 2, 3x plus 2.
If
So-
x minus 2 squared.
So my factored form, we have those so far. 2 worked up here as well, so that means it's a square. And we also had 1, or negative 1 that worked, so we need an x plus 1. It doesn't matter what order these parentheses are in, as long as you have all of them. So then the zeros. If we set each of those equal to 0, we get 2 multiplicity of 2.
-1, -2/3.
All right, so at 2, what's my graph going to do? Bounce. At negative 1 and negative 2/3, it will go through. Y-intercept. If you put in a 0 for all of your x's, you can do it in your factored form or in the original. You should get 8, no matter what. And so then I asked you to draw that graph. So this kind of had everything in it. Hit my y-axis at 8, the x-axis at positive 2, negative 1, and negative 2/3. My end behavior was up, up. So it starts up at negative 1, my graph goes through. Negative 2/3, it goes through. Get your y-intercept. Come back. And at 2, my graph bounces. So it should look something like this.
Among got layers.
All right. So probably wouldn't have you do every one of those things on the same problem on a test, but that's kind of everything that we've done with the graphing and the finding the zeros. Are there any questions on that one? Okay. Let's do a couple from the bottom section, and then I'm going to throw something up here with an I to make sure we know how to handle those. Let's talk about number 5.
Perfect.
Yeah. So if I told you to solve this by factoring, we could group, but what do you have to make sure you do?
Plus 3 -1.
Yeah, we make it plus a negative 3x before we add our parentheses. Then the first group of parentheses, what can we pull out?
X squared.
And you're left with?
3x plus 2.
Second group, what can we take out?
And then
Negative 1 squared.
And then we get 3x plus 2. The reason we took out the negative is because we want these parentheses to be the same. So now they both have the 3x plus 2, so we can take that out. What are we left with?
x squared.
X plus 1, X minus 1.
And x squared minus 1 is the difference of squares. Our directions were to find the solutions. So now if you say each of those equal to 0, what do we get?
Plus and minus.
Yep. Positive and negative 1
Negative.
and negative 2/3. What if we did number 6 on there?
It's a world with.
You could do, what's it called? Then you, something, not something.
Yeah, easy method.
There we go.
So x to the fourth would break into x squared. What multiplies to negative 6 and adds to positive 1? Alright, so if I want you to get the solutions, you can set each of these equal to 0. So we get x squared equals 2. So then we would do square root plus and minus. So we get a positive and negative square root of 2. This one, when you bring over your 3, it's a negative. So what's the square root of negative 3? So my answers are plus and minus the square root of 2 and plus and minus I radical 2. Let's flip it over. I'm going to give you a problem. We'll do it on the back. One thing that I have noticed we tend to have more trouble with is problems involving an I. So doing synthetic with an I. So I thought it might be beneficial to practice that. So let's say I told you the polynomial x to the fourth minus 2x cubed plus x squared minus 8x minus 12 has a 0 of negative 2i. And my directions, find the remaining zeros. Okay. Anytime I give you the first 0, what can we do? Synthetic. So we're going to do the negative 2i, my coefficients. Okay, so 1 comes down. 1 times negative 2i is negative 2i. I cannot add these, so this is just negative 2 minus 2i. So now I'm doing negative 2i times negative 2 minus 2i. Is everybody with me so far? Okay, so negative 2i times negative 2 is a positive 4i. Negative 2i times negative 2i is 4i squared, which is negative 4. So when I add like terms, 1 minus 4 is negative 3 plus 4i. So now I'm doing negative 2i times negative 3 plus 4. So negative 2i times negative 3 is 6i. Negative 2i times positive 4i is negative 8i squared, which is positive 8. And that's good news because now when I add, those 8's drop and we get 6i. So negative 2i times 6i is negative 12i squared, which is 12. Okay, for the moment this looks uglier, but we know something about imaginary zeros. What do we know?
The opposite.
Yeah, they come in pairs. So if negative 2i is a 0, so is positive 2i. If I tell you that I is a 0, what else has to be? Negative I. If I say 5 plus I is a 0, so is 5 minus I. The conjugate always works. That's only with the imaginaries. So when we do synthetic again, we leave off the 0 because that was my remainder. And so we set this up. So the 1 comes down. 1 times 2i is 2i. Those cancel and we get negative 2. Negative 2 times 2i is negative 4i. Those drop, we get negative 3. Give me negative 6i and a 0. So I'm left with x squared minus 2x minus can do easy method. Multiply -3 and add to -2.
-3.
So my question was the remaining zeros. So I gave you -2i. You give me the rest. So we had +2i, +3, and -1. All right. Questions there? All right. We're going to do another one. Is there anything specific you guys want practice over? Just want me to put one up here? Okay. All right. So here's a polynomial.
That's a trick for me.
I thought you were gonna write out what
All right. Try this, guys. All right. What's our degree?
8.
8. In behavior, because it's a negative. Okay, zeros and multiplicity. So if it's not factored, you have to get it factored. Now sometimes we did that with p's and q's. Would p's and q's even be an option here?
No.
No, because we don't have a p. We don't have a constant. So what could you do instead?
GCF.
GCF. They all have x to the 6. Since the first one is negative, I would take out a negative x to the 6. So that's x squared minus 4x minus 5.
I'll put x squared.
So multiply -5 and add to -4 would be -5 and +1. So my zeros would be
0, 5,
0, multiplicity, 6, 5, and -1. So my 0 would bounce. The 5 and -1 would go 0. How do we find a y-intercept? So if all my x's are 0, you get 0 times -5 times 1, which is 0. So on my graph, I know both ends are pointing down. I hit the axis at 0, 5, and -1. Okay, we're going to start down here. We go through the -1, bounce at 0, through at 5. Okay, you can use calculator to double check your graphs, but make sure your answer is supported by all the work you have. Does everyone know what to expect on your test tomorrow?
Yes.
Okay. If you do have any more questions, please come see me.